Okay, so our first step for synthetic division is finding the root of the divisor. So you would set x plus 10 equal to 0, and then you would solve for the x. Okay, so negative 10 is your input. And now you check, do any terms get skipped? The exponents go 3, 2, invisible 1, none. So nothing got skipped. No placeholder zeros are needed. We do want a 1 as the coefficient of the x cubed, right? So 1x cubed, 6x squared, negative 30x. And then the constant is also included, the 102. Okay, the two steps are you add downward and then multiply diagonally. And remember, you multiply by the input always. Okay, and then once you have that, you need to put the variables back in. The original problem was x to the third, but since you're dividing it, it's going to always get knocked down by 1. So the first term in the answer will be x to the second, right? So this would be the x to the second, this would be the x to the first, then the constant, and then the remainder. Okay, so 1x squared, or just x squared, minus 4x. Positive 10 is the constant, so plus 10. And then because our remainder is not 0, we need to add the remainder fraction. The numerator is the 2. And then sorry, not that. The thing you divided by is your denominator. Okay, so that's the answer that I came up with. Okay, but I have a way of checking it myself. Because again, on the quiz, right, I'm not going to be able to tell anyone if they did a problem correctly or not. They're going to have to know how to check it on their own. Okay, so again, just like how you could check, is 94 divided by 2 truly 47, you check division by multiplying it back together, right? So you multiply 47 by 2, and you check if it equals the starting value. Okay, so in this case, we would multiply the division answer by the thing we divided by to see if it equals the initial value. Okay, so this one's going to be a little bit tricky because we haven't really multiplied by fractions like this before. So I'll show you how you can do this. Okay, so you've got x plus 10 and then times what we think is the answer. Okay, and our hope is that this will equal that. Okay, but how do we deal with this remainder term? Uh, what we can do is we know that this is going to multiply all four parts of the inside, but why don't we group together the three over here and then treat the remainder separately? Okay, so we can sort of split it up. Again, the outside is still going to multiply all four, but we'll do these three terms as one group. And then separately, we'll multiply the x plus 10 times the remainder term. Okay, so basically, you know that if you had something like, 5 times 2 plus 7, you could split this up to 5 times 2 plus 5 times 7, right? You're distributing. It's the same idea here, right? The x plus 10 is still multiplying the whole thing. We're just doing these three together and this one separately. Okay, so the reason we do that is if you look over here, the x plus 10s will cancel out. You have identical x plus 10 factors. So you're left with just 2 over 1 or 2. Okay, now over here, you do need to distribute it out normally, right? So you'd have x cubed minus 4x squared plus 10x, and then plus 10x squared minus 40x minus 100. Okay, so combining like terms, x cubed plus 6x squared minus 30x minus 100. And don't forget, you still have this plus 2. Okay, so combining like terms. Negative 100 plus 2. Sorry, that should be positive 100, my mistake. Positive 100 plus 2 is plus 102. Okay, and that does match the initial value, right? So that's how we can check our answer. I don't really see what you did. Let me finish this first, and I'll come take a look, all right? How would you simplify it? What could you do with this? Yeah, there's nothing to combine. None of these are like terms. So yeah, this is already fully simplified. Okay, let me do the other problem as well. So k minus 2, the root of that set it equal to 0, positive 2. Exponents go 3, 2, 1, none, so no zeros needed. Okay, positive 1k cubed minus 1k squared minus 1k, and then constant minus 2. 1 plus nothing is 1, times 2 is 2, plus negative 1 is 1, times 2 is 2, plus negative 1 is 1, times 2 is 2, plus negative 2 is 0. Okay, and now you put the variables back in. Since you started with k to the third, it gets knocked down to k to the second, then k, then constant, and no remainder for this one. Okay, so just k squared plus k plus 1. No fractional remainder. Okay, so I think that's the answer, but again, we want to get in the habit of checking our own answers. So we multiply together what we divided by what we think is the answer. Okay, so k cubed plus k squared plus k minus 2k squared minus 2k minus 2. Okay, so we do end up with the starting value. So that means that k squared plus k plus 1 was indeed the correct division answer. Okay, so again, I saw many of you correctly do the division, but yeah, this is how you check your answer, including if there's a remainder involved. Okay, so again, I would definitely recommend that you check your own answer by multiplying on the quiz next class, as well as the upcoming test. Okay, so any questions on this section? Yeah.
I think I'm a little ready for the quiz. Okay.
Good.
Easy for me.
All right. Let's go ahead and introduce our last topic before the quiz. So we have something called the remainder theorem. We've been dealing with remainders over the past couple lessons. Okay, so all the remainder theorem is saying is that if the remainder is 0, then the thing you divided by is a factor, right? And it's the exact same thing as it is with whole numbers, right? Like if you divide 7 by 2, there is a remainder. So 2 is not a factor of 7. But if you divide 8 by 2, there's no remainder. So 2 is a factor of 8. Okay, so let's look at this first question. Is b minus 7 a factor of b to the fourth minus 8b cubed plus 62b minus 34? Okay, so according to the remainder theorem, to answer that, you try dividing them and you see if the remainder is 0 or not. Okay, so we know that if you want to divide by this, you need to start with the root, in this case, positive 7. And now we need to get the coefficients out. But let's be careful, right? Because it goes b to the fourth, b to the third, b to the invisible first, no b at all. We skipped b to the second. Okay, so we need to add in a placeholder plus 0b squared in order to keep everything in the right spot. Okay, so you've got 1b to the fourth, negative 8b to the third, 0b to the second, 62b, and minus 34 as a constant. Okay, 1 plus nothing is 1, times 7 is 7, plus -8 is -1, times 7 is -7, plus 0 is -7, times 7 is -49, plus 62 is 13, times 7 is 91, plus -34 is 57. Okay, so we do have a remainder, right? The remainder is not 0. Okay, so that means that the thing we divided by did not divide evenly. Okay, so since the remainder is not 0, b minus 7 is not a factor. Okay, so now let's take a quick look down here. I ask, is -5 a root of that thing? Okay, so here I'm not giving you a factor, I'm giving you a potential root. So here you use the -5 directly. You don't like set it equal to 0, you don't switch it to +5, right? Because there's no variable here. So since I'm just giving you the number to try directly, you use the -5 itself. Okay, and then over here, when I ask for a 0 is the same thing as a root. Okay, so yeah, the other three questions all have slightly different wordings, right? But the idea is the same. You do synthetic division and you see if the remainder is 0 or not. Okay, but make sure you answer the actual question, right? Tell me yes it is or no it is not. Okay, so go and take a couple minutes, please, and try the other three problems in this section. Let me finish this bottom left problem. So again, you just use the -5 itself. You don't switch it because it's not b minus 5, then it would be +5, but you're directly told to try -5. Now, what you also needed to recognize is that we're missing the n to the fourth term. Okay, so you got to squeeze in a 0 n to the fourth. Okay, so 1, 0, -25, -7, -37, -18. Okay, so the remainder is -8, which is not 0. Okay, so that means that -5 is not a root. Okay, so technically what we were doing here was we were actually evaluating the x value of -5, and we found that the y value at -5 was -8, right? So the y value has to be 0 for it to be a root. Yeah, so the point -5, -8 would be on the graph, but that's not a root. Okay, now going back to the top right. So p minus 2 as a factor. So here we do need to set it equal to 0. So +2 is our input. 4, 3, 2, 1, 0. No missing place values. Okay, so 1p to the fourth, -8p cubed, 10p squared, 2p plus 4. Okay, we do get a remainder of 0. So that means that p minus 2 is a factor. Okay, and then lastly, is -2 a 0, which is another word for a root of this? Okay, so again, you use -2 directly. You don't switch it to +2. 4, 3, 2, 1, 0. Nothing skipped. Okay, we do get a remainder of 0. So yes. Okay. So we're going to be using this as part of the next step. So are there any questions about the process of determining if something is a factor or if something's a root? No? Okay. All right, so now we're going to use synthetic division to factor polynomials. Okay, because we've seen that it's very beneficial to have polynomials in factored form, right? Like on our previous lessons, right? When you're given a polynomial in factored form like this, right? You can easily tell the zeros, right? -1, 1, 5, and you can sketch the graph from there, right? So our goal for today is to be able to turn standard form into factored form, right? Because if I asked you to sketch a graph of this, you would know the end behavior and the y-intercept, but that's it, right? You don't know where the zeros are. You don't know the multiplicities of the roots. So that's why we need to know how to factor this. Okay, so now very nicely, we've been given one factor to start. Okay, so again, it's just like if I asked you, what is the prime factorization of 38? Right, well, if I tell you that 2 goes into it, you just do division to figure out, well, 2 times what equals that number. Okay, so yeah, same thing here. If this has x plus 4 as a factor, to find the other factor, we'll divide the original polynomial by the given factor. Okay, so this is going to be exactly what we basically were just doing. So since you're given a factor, you need to find the root to start.
This is the time, please.
The top screen. Okay, so now we need to check, are there any missing terms? Here we do have a missing term, right? There's no x to the third. Okay, so we're going to squeeze in a plus 0 x to the third power.
Tracy, one more time on the top one.
-2. Here, you can look off this one. Oh, sorry about that. Okay, so 8, 32, 0, 2, 9, and 4. Okay, so 8 plus nothing is 8, times -4 is -32, plus 32 is 0, times -4 is still 0, plus 0 is still 0, times -4 is still 0, plus 2 is 2, times -4 is -8, plus 9 is 1, times -4 is -4, plus 4 is 0. Okay, so we did get remainder 0, which does indeed confirm that x plus 4 was a factor. Okay, but let's make sure we follow the instructions for this section, right? So the instructions here are to factor. Okay, so again, if I ask you to factor 38, the answer is not just 19, it's 2 times 19. Factor means rewrite as multiplication. Okay, so what we need to do here is we need to turn this bottom row back into a polynomial. Since we started with x to the 5th, when you divide it by x, you knock it down to x to the 4th. Okay, again, it always goes down by 1. Okay, and then from there, you get x to the 3rd, x to the 2nd, x constant, and no remainder. Okay, so you got 8x to the 4th, no x cubed, no x squared. You have positive 2x, so plus 2x, and then positive 1 for a constant, so plus 1. Okay, so this is the answer to the division, but this is not the factored form. Because again, when you factor 38, it's not just 19, it's 2 times 19. Okay, so the factored form, you take this division answer and you multiply it by the thing you divided by. Okay, so now you would check if this parentheses could be split up even further. But at the moment, we don't really know how to do that, right? It's not a quadratic. It's not, it's x to the fourth, not x squared. So we can't really do our normal methods. So yeah, we'll just leave it here. Okay, so let's start one more together. Again, I'll just jump down to c of x. Okay, so here you're told that 1 is a root. So again, you use that number directly. You don't switch it to -1. Check the exponents. 3, 2, invisible 1, but there's no constant. The constant is a place value, so you do need a 0 at the end. Okay, so we'll take 1x cubed minus 2x squared plus 1, so positive 1x. And then again, we do need the 0 at the end. Okay, 1 plus nothing is 1, times 1 is 1, plus -2 is -1, times 1 is -1, plus 1 is 0, times 1 is 0, plus 0 is 0. Okay, now we turn that bottom row back into a polynomial. The initial value was x to the third, so when you knock it down by 1, now it's x squared, then x, then the constant, then the remainder. Okay, so x squared minus x, and no constant, no remainder. Okay, but again, when you factor, you don't just write the division answer, you write what you multiplied by. Okay, so this one's a little tricky. Does anyone think they know what factor we're gonna multiply the pink one by? Go ahead, Nick.
Excellent.
Very good. The root of x equals +1 corresponds to the factor of x minus 1. All right. So again, it looks like you're dividing by 1, but the factor whose root is 1 is x minus 1. Okay, so now for this problem, we can actually even factor a little bit further because x minus 1 is done. It's already 1x to the first power, but the x squared minus 2 has a GCF. It has a common factor of x. Okay, so we can pull that x all the way to the front. And that leaves x squared divided by x is x. Negative x divided by x is -1. So now we actually have identical parentheses. So we can further simplify it to x parentheses x minus 1 squared. Okay, so yeah, remember we reviewed regular factoring a couple of days ago. So you look at this first parentheses in pink, you notice it has a GCF. So that means to fully factor it, you do need to factor that GCF out. Right, if you stopped right here, that would not be considered fully factored. All right, so go ahead and try the other two in this section, please. Question. So because the two parentheses are applying each other, you don't need to affect both of them. That'd be like sort of double complement, I guess. You only need to take it out of one of the parentheses. Yeah, if it were in standard form, if they were on glued together in parentheses, then you have to divide every single thing by the yeah. But if you look back at the original problem, actually, these it was CFC event, so we don't know we can out. But yeah, because it's in factor form, you get to treat to the factors separately for the purposes of factoring. Yeah, that's another benefit of factor form. Yeah, you can factor out of only one parenthesis. Okay.
So negative one is like.
So I was gonna say that's okay, sure, yes. No, I do want you to do it much. However, remember how over here, like this answer is only part of the factor four. You also need to subtract of what the divider's like over here, right? This is part of the answer, but what else? Right, so that is part of the factor four.
Yeah.
A good start, but check if anything can be further split up. Okay, so this one you are off to a great start, but can either of these be further factored? So not this one, because this one's already next to the first power, but this can be factored further. So you got to think back to your strategies. And this one right here. This is very good. However, I'm not sure where this, like, did you forget about the core?
Minus negative one
Find out over here, check if the initial answer for the document. Want to check if the parentheses.
Okay, yeah, I got it. I got it.
Yeah, it's like, are you trying to? Yeah, so, the way to do it. Start, it's not considered a factor. Technically, two factors.
On the right track. Okay, I got X+. If you get X squared minus plus 12, well, did you forget this? It goes from.
So, is there a way you can check if your factoring is correct? Yeah. If you didn't get zero, double check.
No, you got it now. You got it in the corner and then you go.
Right here, negative 5, negative 1, applies to negative 6, my opposite. Okay, so how would you technique yourself? Right, and you want to, right? Yeah, it's like you correctly. Yeah. But not. Someone asked that if he gets back. You're right. Okay, so it's a trinomial return, so you put two parentheses. And then, yeah, the first box is by the
Zero, like that. Negative 2 is The four is. The one. Zero.
Take about 30 more seconds and we'll go over them.
Okay.
I could, but I just want to make sure you know, like, if this were a test day, how would you check it yourself?
Oh.
Sorry, those are these ones, cool, right? I wanted to, like so many of that color scheme. Yeah. Wait, sorry, yeah, I was thinking about it. And then there's also a couple with this. It's not cutter. It is cutter. Okay.
There's only like one more. Which is this.
Which one has the lid?
Oh.
Oh, Barnett. Yeah. Well. Okay, so sorry, back to your question. Yeah, so for this one, you're off to a good start, but it's not considered fully factored yet because the trinomial here can be further split up. Right, so you want to think back to your math 2 factoring. Like ignore the rest of the problem now, just try to split this into 2 smaller parentheses. I'll show seconds. Okay, let's go ahead and move on. For the top right problem. Oh, whoops. Oh well. Sorry, the x plus 1 has a root of -1. 3, 2, 1, 0, nothing gets skipped. So no zeros needed. Oh, sorry, I messed up. What am I doing? Sorry, I messed up there. Okay, so this translates to x squared minus 6x plus 5. And then the other factor is x plus 1. Okay, so this answer is not considered fully factored yet. The x plus 1 is fully factored. You can't split that up any further. But the x squared plus 6x, minus 6x plus 5 can be further split up. All right, so this is a trinomial. So again, I highly encourage this method. We know this spot times this spot is x squared, so it's got to be x times x. This spot times this spot multiplies to 5. So the immediate thought would be 1 plus 5, or positive 1 times positive 5. But because the middle term is negative, I know it's going to be -1 and -5, right? 2 negatives still multiply to a positive, but they would add to a negative in the middle. Sorry, that should be a 5. Okay, and so yes, it's okay if you switch the order of the parentheses. But yeah, those are the 3 factors. Okay, and then over here, so you may remember from that factoring review day, like one of the extension problems was how to factor like a sum of cubes. Okay, so you might recognize, okay, well, x cubed is x cubed and 8 is 2 cubed, right? So naturally you might try 2 or -2. So let's see, is -2 a root of this? So this would be 1x cubed plus 0x squared plus 0x plus 8. Okay, so 1, -2, -2, 4, 4, -8, 0. Okay, so -2 is indeed a root. Okay, so we've got, start with x cubed, so that goes down to x squared, x constant. Right, and if -2 is a root, then the x plus 2 would be a factor. Okay, so yeah, here is how you would factor this sum of cubes, right? Again, you recognize that 8 is 2 cubed. You can try 2, but 2 is not going to work, right? If you try 2, everything's positive, so everything's just going to get bigger. Right, so positive 2 doesn't work, but negative 2 does work. Right, and then from there you can factor the trinomial. Okay, so now can you split this one up further? You can try, but it's not going to work, right? You can try, okay, is it plus 2 plus 2? No, those would combine to 4x in the middle, right? Is it minus 2 minus 2? No, those would combine to negative 4x. Is it minus 1 minus 4? No, those would combine to 5x, negative 5x. Okay, so you can't further split this one up. Okay, so yeah, like there is a formula for this special situation of a difference of cubes, but you could always do it this way if you forget. Okay. So questions here? Okay, so at the end, we'll go back. I remember last class we didn't finish the last page of the handout, but let's finish today's first. Okay, let's go and turn to the backside. Okay, so this time we're given not only the standard form equation, we are also given a graph of the function. Okay, but the instructions are the same, is to come up with the factored form. Yes, and we've done this before, right? We've just looked at the graph and said, okay, here's a root multiplicity 1, here's a root multiplicity 2, right? So yes, that would work in some cases, but not always, right? So like if you look over here, we can't tell what this root is at. So we need to find the, oh, what happened there? Fell off. Oh, I think someone else just took it. Yeah, sorry. Yeah, you'll be next. Okay, so because the graph does not always cross nicely at an integer, we still need to know the factoring method. Okay, so like what would we do here? I might recognize, okay, there's clearly a root at x equals negative 1. Okay, so let's go ahead and do synthetic division with negative 1 as our input. We've got negative 1 x to the 4th plus 1 x to the 3rd plus 2x squared plus 0 x to the 1st plus 0 as a constant. Okay, so make sure you put those extra zeros at the end. Okay, so we do indeed have a remainder of 0. Because we started with x to the 4th, that means that this will get knocked down to x to the 3rd. Right, so negative x to the 3rd plus 2x squared. Okay, and no x, no constant, no remainder. Okay, and then don't forget, when we're factoring, you need to turn this into its own factor. Okay, so again, if negative 1 is a root, the corresponding factor is x plus 1. Okay, by the way, why did I start with this root and not this one or this one? I could have. It doesn't matter what order you do them in. Okay, so now let me go ahead and move on to the middle, right? So we see another root at x equals 0. Okay, so what do we do with that? Right, you've been told for years you cannot divide by 0, which is still true. You can't divide by 0. However, you're not really going to be dividing by 0, right? Like over here, it looks like you're dividing by negative 1, but you're actually dividing by x plus 1. Okay, so for that reason, you can use 0 as the input in your synthetic division. Okay, so we're just going to divide into this part. The negative 1 x cubed plus 2x squared plus 0x plus 0. Okay, let me write it out. Okay, so again, this is going to look kind of weird, but -1 plus nothing is -1, times 0 is 0, plus 2 is 2, times 0 is 0, plus 0 is 0, times 0 is 0, plus 0 is 0. Okay. Sorry? A -1, right? From right here? That's where I got the -1 from. Okay, good. Okay, so this bottom row, again, we started with x cubed. So this gets knocked down to x squared. This is 2x, right? No constant, or the constant is plus 0 if you want. And then no remainder. Okay, so don't forget, we still have the x plus 1 from earlier, right? So when we split the purple part up, the red part is still there. Okay, but we also need the corresponding factor of the root of 0. Okay, so again, when you do synthetic division by -1, the actual factor is x plus 1. So when you do synthetic division by 0, what factor did you actually divide by? Any ideas? X, or x minus 0, right? Which is just x. Okay. So you could keep going, but you could also recognize at this point that you've got a GCF. So because this is already in factored form, it's not fully factored, but it's already factored. Everything is multiplying. You are allowed to take the GCF out of just a single factor instead of having to do the whole thing. Right, so here you might recognize that, oh, both of these have an x, right? So we take the x out front to join the x over here. Okay, and then lastly, we can combine these together. Okay, it might have been better actually if we factor out a negative x, right? Because having a negative inside is kind of tricky to look at. Okay, so sorry, let me change my mind. Okay, so if you divide by -x instead, then this becomes positive x, and this becomes -2. And then we take the -x out front. So when it multiplies the x that was there from earlier, we get -x squared. Okay, so this would be fully factored, right? You can't split this up, you can't split this up, you can't split this up. Because we already had the blue x from earlier, from when we divided by 0. Then over here, we recognize there's a GCF. We can divide -x evenly into both terms. So when we take the -x out front, it multiplies the blue x that was already there, and they combine into a -x to the power of 2. Okay. All right. So any questions here? Okay. And so this last one, we're starting with this. And what root do we want to use? Again, we can't tell what this root is. It's somewhere between -1 and -2, but it's impossible to tell exactly what. Okay, so we can't start there, so let's start here instead. Okay, so we'll start with the root of x equals 0. Okay, so we've got 1x to the 4th plus 0x cubed minus 1x squared plus 1x, and then plus 0 as a constant. Okay, we do get remainder 0. Okay, so we started with x to the 4th. So this gets knocked down to x to the third. So 1x to the third, no x squared, minus 1x, plus 1 as a constant. And as in the previous problem, if you did synthetic division by 0, you actually divided by x. Okay, so now you would check, can you split this one up further? It's, again, not a quadratic. It's not x squared. It's x to the third. There's no GCF in here. You can't take x out because the constant cannot be divided by x. Okay, so this is as far as we know how to go. Okay, even though we know there's some sort of root here, it's probably going to be irrational. It's going to involve a radical, and that's beyond what we know how to do. Okay, so we would just stop here. Okay, so that brings us to the last topic on this worksheet. Oh, yes, question first. Annabelle, do you have a question? No? Okay. All right. So then the fundamental theorem of algebra. So, fundamental means like kind of like, something really important that everything is based on. Here's like a long description of what it states. Every polynomial has a root that includes real numbers because complex numbers have a real component. But what we need to know about this, any polynomial of degree n has n roots. Okay, so if it's degree 3, it has 3 roots. Degree 5, it has 5 roots. Degree 11, it has 11 roots. Okay, so this may not match with what you think you've seen above, right? Like if we look back over here, right, this is degree 4, but we only see 2 roots, right? So how can this be true? What we need to know here is that some roots may be repeated or complex. Okay, so our last goal for this handout is to be able to find all the roots of a polynomial in standard form. So let's do this top left one together. Okay, so again, we're given a polynomial. We can't do our regular factoring, right? Like we've learned factoring by grouping, but it's not going to work. There's no way to make these parentheses match. Okay, but again, that just means we have to use our new method. Okay, so if x plus 5 is a factor, that means that -5 will be the root. We have 1x cubed, positive 2x squared, minus 19x, minus 20 as a constant. Okay, so yes, x plus 5 is indeed a factor. Let's go ahead and turn the bottom row back into a polynomial. We started with x to the third, so this gets knocked down to x to the second, right? So 1x squared minus 3x minus 4 as a constant, no remainder. Okay, and then don't forget, when you divide by synthetic division by -5, you're actually using a factor of x plus 5. Okay, so let's leave the x plus 5 alone, but let's try to factor the blue part further. Right, it's a quadratic trinomial, so I'm going to use this method. This spot times this spot is x squared, so x times x. This spot times this spot is -4. To get to a negative answer, you need one positive and one negative. because the middle term is negative, I know I want the negative number to be bigger than the positive number. Okay, so instead of doing like 2 and -2, I'll do -4 and +1. Right, -4x plus 1x does indeed combine to -3x. Okay, so now you got to make sure you do what the question asked you for. This would be the factored form, but that's not the instruction. The instruction is to find the roots. Okay, but factored form is very good for finding the roots, right? You just set each factor equal to 0. Okay, so x plus 5, yeah. Okay. So in the multiplicity, I forgot to put it in the instructions, but let's go ahead and write the multiplicities also. Okay, so again, because the x plus 5 has an invisible exponent of 1, you can put multiplicity 1. Okay, now from this factor, you get a root of x equals -1. Again, exponent is 1, so multiplicity is 1. I mean, from here, you can go straight to the roots, right? It's you don't need to show this part. Okay, and then for this last one, again, you don't need to show this step, but you need to write that the root is x equals +4, and again, the multiplicity is 1. Okay, so that part is your answer. Okay. So go ahead and please start with n of x. If you finish that one, you can continue on to the others, but we might not get through all of them because I want to go back and finish last class's page. Okay, so go ahead and just start with n of x, please, and we'll come back together in a few minutes.